Flexible display is a dream element the whole world is paying attention for its excellent portability, as the display is very thin like a paper thickness, bendable, foldable, and the fabrication of more than 100-inch supersized display is also available. Although various prototypes have been presented, it has not reached a commercialization stage yet. Dr. Lee Kun-hwan's team of Korea Institute of Materials Science has brought the possibility of commercialization of flexible display forward a great deal by developing a new barrier and transparent conductive coating technology, and improve the competitiveness of the next-generation display field by obtaining domestic and overseas patents on the side display unit using the technology. Basic structure of a prototype flexible display devices is as follows. Flexible display devices use a polymer film instead of a glass substrate, and also use films or thin coating layers as materials for encapsulation. And it secures overall flexibility by fabricating the transparent electrode thinly much more. However, there is a disadvantage that such structure is vulnerable to moisture and oxygen penetration. Therefore, barrier coating for preventing their penetration is positively necessary.
많은 연구자들은 미래의 디스플레이 소자로 플렉서블 디스플레이 소자를 예상하고 있습니다. 보호막 코팅 기술은 이러한 플렉서블 디스플레이 소자의 기판으로 사용되고 있는 폴리머 재료의 가스와 수분 침투를 억제하는 기술로서 방막 재료는 주로 치밀하면서도 투명한 세라믹 소재를 사용하고 있습니다. 이번에 저희 연구팀이 개발한 기술은 진공 상태에서 플라즈마 에너지를 이용하여 방막을 제조할 수 있는 방법입니다. 보호막 형성의 경우 플라즈마 에너지를 이용해서 저온에서 화학 반응을 유발시켜 치밀하면서 균일하고 밀착성이 우수한 산화물계 방막층을 제조할 수 있는 방법으로 이번에 개발된 기술은 비교적 간단한 공정을 이용해서 효과적으로 가스와 수분 침투를 억제할 수 있는 방막 제조 기술입니다.
Our research team developed a technology that manufactures superior barrier films more economically using both sputtering and plasma-enhanced chemical vapor deposition methods. It is a technology that forms an aluminum oxide transparent thin film on the polymer substrate using sputtering method and a silicon oxide thin film on it by using PECVD method. Common barrier coating technology deposited a silicon oxide thin film on the polymer substrate using PECVD method has a disadvantage of generating fine protrusions on the surface due to plasma damage, which deteriorated barrier properties. On the contrary, the barrier film manufactured by this technology has a smooth surface, and the barrier property is also excellent, as aluminum oxide layer formed on the polymer substrate by sputtering method protect the substrate surface from plasma damaging. Meanwhile, thin film developed by this technology shows excellent properties in folding endurance test comparing to existing films, and its excellence has been proved as much as WVTR value reaches the range of 10,000th gram per square meter per day. Transparent conductive coating is a core technology for development of flexible display devices along with a barrier coating. To commercialize flexible display, following material properties must be secured in transparent conductive thin film. But what has become an issue at current development level are sheet resistance and flexibility. Transparent conductive thin film developed by our research team improved such a problem considerably.
저희 연구팀은 물리증착보의 일종인 스퍼트링 기술을 이용하여 얇은 두께에서도 높은 전기 전도성을 갖는 독특한 구조의 투명 전도성 방막 제조 기술을 개발하였으며 이 방법을 활용하면 플렉서블 디스플레이 소자의 실용화에 가장 큰 걸림돌로 지적되고 있는 플렉서빌리티와 전기 전도성을 획기적으로 개선시킬 수 있을 것으로 기대합니다.
substance that is most widely used today is ITO, which deposit on the glass substrate through more than 300 degrees Celsius of deposition temperature. However, maintaining less than 80 degrees Celsius of low temperature is necessary to deposit a thin film on the polymer substrate, which is used for flexible display. But in such a case, roll-to-roll process must be used, and there are also disadvantages of thickening thin film, making resistance value higher and breakable. Transparent conductive thin films ever developed have a ITO-AG-ITO structure basically. As shown in the graph, it has excellent sheet resistance properties, less than 10 ohms per square inch with thin film thickness, but had a disadvantage of a low transmittance. The coating structure developed by our research team is ITO silver oxide ITO, and we improved innovatively disadvantages of present transparent conductive oxide films with this new method. Especially, it shows excellent electrical and optical properties by adjusting thickness and composition of silver oxide interlayer. Having less than 10 ohms per square inch of sheet resistance and more than 90% of transmittance in less than 70 nanometer thickness of thin film is evaluated to be applicable directly to commercialization of flexible display devices. After it was introduced on the cover of Plasma Processes and Polymers in September 2011, more than 20 theses on this technology have recently been published in the excellent journals including Advanced Functional Materials, achieving recognition for its academic and industrial value through registration and application for 2 international patents, 6 registrations, and 8 applications for domestic patents. Meanwhile, functional coating technologies on substrates for flexible display and the design of side display unit using the technologies patented in the USA in 2014 suggested a possibility capable of overcoming the limitations of present displays. The most advanced country of display, Korea. Another challenge to continue the honor. This technology will become the strong foundation for bringing commercialization of flexible display forward.